recording.
Okay. So everyone, where's your GrabCAD folder? Is it linked?
I got you.
Okay. Okay, sweet. Okay, so everyone here, I'm assuming, is in the GrabCAD, and essentially, in years past, everyone's had to download drawing templates, go to a certain file folder in SolidWorks, and put the file there, etc. And then if we need to update that template, we'd have to redistribute that template to everyone. Sort of a pain in the butt. This year with the NX templates, in the Mark IV folder, there is a NX templates folder, and within that, there's a variety of different sized drawings, all in inches, because remember, everyone's modeling in inches in Imperial. And there are two palette files, they're called. And where's open to choose other? I want to open it in Notepad. And so in these files, there's a bunch of different code that I had to copy that calls out the different drawing files in this folder. And if we ever need to update a drawing template, I just update that. It'll update for everyone. But you guys don't really care about that. You just want the drawing templates on your computer. So instead of having to go put file somewhere, all you need to do is just double click each of the palette files, and those will open up tabs in your NX, in your little tabby guy on the side. I forgot what they're called. They're just tabs or templates or whatever. So I made them the same logo, probably not the best idea, but you can read that one is a sheet template and one is like a non-master drawing template. So if I just open this tube, for example, okay, it's here. All right, so once you have your two little tabs on the side, and you have your like final CAD done for your part, the process for making a drawing is this, all you have to do is for the non-master drawing template thing, select whatever sized drawing you're wanting to do. So let's do a D-size drawing for that, and it'll automatically open and then go to put your first view in the drawing. So you can just click that there or whatever. And at this point, it'll automatically let you do the 3 or however many different views you want off of it. You can just close that. And now you have your drawing. And in the assembly navigator, we can see that there is this new file that has GWG2 on it. And this is technically your drawing assembly. So this is an assembly that your part that you're doing your drawing for is within. So let's say you're doing a drawing for this tube, but on this drawing, for reference, you need to include another component. You can add that component into the drawing assembly and put it on a different layer and have it as a crosshatch or something. And so now once you, the first step, once you have this, this assembly file, is you'd want to go you just want to save that to GrabCAD. I'll just put it in here for now. And essentially what you're going to want to do for your part numbering for this, for the file name, is it's going to be the OG23 dash, obviously in all caps, -FR. But then before you start your number, you're going to just put a lowercase d in front of that. and then do your like A2001 or your like 3005 or whatever, and then your description tube, and then put drawing after it, so that we can see that they're the drawing sort of thing. And then just save that in the exact same folder that your part CAD is saved in. So then in the part tab, we can see that there's a sheet and then like the view in that sheet. The way that I've set up the drawing templates, there's a couple different ways to do it. This is the more like simple run-of-the-mill, like easy way, not all integrated. So if you need to change the scale, so the size of your parts on your sheet, in the part navigator, go up to sheet, right click that and go edit sheet. And then here you can change your scale to like whatever size you need, sort of thing. Whoops. Edit scale, let's go to 1:1. All right, so one thing that you just saw there is the way that these templates are set up is to change the size of your drawing. You can't just go like D or like E in this menu, because that what it does is the temp or like the title block isn't attached to the corner in this. It's separate. So if you need to do a different sheet size, what you can do is in your two little palettes on the side, there's the sheet template guy. And for that, you can pick a different sheet, and then you can go back and you see, okay, look, now there's this C size sheet in there. And then you can go to your first sheet, copy your view, go to your second sheet and like paste it in. And now it's on the different size sheet. Unfortunately, that's one of the little gripes of the way that I've set up the template this year. But I don't think it's the biggest deal in the world. And then you can just delete your old sheet. Yeah. Any questions so far? No. Okay. Oh, Aiden.
How do you fill in all the information in the
Right. That was the next thing. Okay, so in this bottom corner, we have a lovely title block with the logo and all this jazz. One thing for all of our parts is we sort of have to think about tolerances and our manufacturability. So these are just standard ones that I've pulled from Multimatic. But these tolerances obviously aren't necessarily obtainable for certain parts, and I think they're in metric still. So when you're doing your drawing, make sure you update the tolerances. And if you have questions about what tolerance we could achieve on a certain part, talk to Kieran or myself, and we can figure out what sort of tolerance you should put on something. Other fields that you're responsible for filling in is the date that the drawing was created, the mass of the part, material, the part number, and a description of your part, and then your initials for who drew it, the scale, size, rev, and sheet number all update automatically. And I think this might do it. But to update all this info, what you go is File, Properties. And then this first section here, like the No Category section, is where you'd update all that info. So for date, you just go in, change it here, press the check mark, and it updates. So if I go A. Ackerman, because I'm Kieran's brother now. Whoops. And hit enter, you see that updates in there, and then I'll hit OK. And now, originally when you click that, it hasn't updated the drawing, but you can see here in the tree, that sheet is now not up to date. So simply just go right click and update that sheet, and we can see that the name's changed. So if we go back to the properties, so yeah, drawing number and part number are both things that you'll have to put in. Essentially, it's the same number, just twice. You can't connect the two easily that I could figure out as of yet. So we'll just go with that for now. You only really have to fill this out once. So yeah, that sort of goes over creating the drawing, getting the size and scale, and our initial and our template there in the bottom. The next thing would be the different tools for making your drawing. So essentially, all of the exact same as SolidWorks. All of the things are like selected from stock. So you don't have to worry about anything hiding. I guess over here, there's some that you might be hidden. But other than that, everything's there. So if you need to do a new base view of something, you can pick whatever view you need. And then like projected view just as a projected one off of like the side of the part sort of thing. Yeah, all of these are similar to what you guys would have had to do in your SolidWorks class, but the NX version. So yeah, it shouldn't be too bad. For dimensioning, there's rapid dimension, which simply is just easy peasy, automatically like assumes what you're drawing or like what the geometry is. But you do have the option to select individual drawing fields. And one that is useful because Graydon figured it out and we figured it out on the chassis drawing is with rapid dimension and with like the linear dimension. If you're on inferred and you click like two edges, like here it automatically does the 0.75, but if your part's not perfectly aligned to the view that you're doing the drawing of, it can sometimes like your thing is 0.75, but because of like the way the view's oriented or whatever, it's picking like a different point and it's like 0.745 or something. So if you're ever getting like weird dimensions to what your drawing's supposed to be, instead of inferred, go to like vertical, and that'll do the vertical between like those 2 points, guaranteed sort of thing. So yeah, all those guys, like note section, if you need to add notes, fairly simple, etc. For assemblies, a BOM in SolidWorks is called a parts list in NX. And so this, we can default to inserting them in this top left corner. Whoops. No, whoops, I want to. And when you do a parts list, it comes up in like that tree or whatever. And so in this menu, there's the all levels, top level only, etc. So you'll want to play with that. Here we can see the child versus subchild part. This is actually important for doing actual assemblies. So the part, this tube that I put in is simply just a part file. It's not a drawing of an assembly. So when you do a drawing of an actual assembly where the part that is in the drawing assembly is an assembly, for the parts list, what you're going to want to do is you're going to want to do subchild part, because that's going to change the BOM from pulling the BOM of the drawing assembly to be the BOM of the actual assembly that we're doing the drawing of. And you can include subassemblies, etc. You'll have to play around with it. But the other nice thing compared to SolidWorks is you can simply press the show balloons thing and click your isometric view for when you're doing a thing. And it doesn't show it in here because my palm isn't set up right, but it'll automatically pop up all of the balloons for all of the different parts in that drawing, and then you simply just have to drag them around and arrange them as you wish. Yeah. Any questions as of yet now? Questions, comments, concerns? Can you say that louder?
This is so much better than SolidWorks. It's not even fun.
Why is this better than SolidWorks?
Because SolidWorks is freaking terrible for these drawing things. Nothing snaps. You can't do anything. It's like all that. I think you've been doing SolidWorks wrong. Yeah, SolidWorks is the same as SolidWorks.
Hey, either way, Ron said it's better, so that's all I need to hear.
Can you show us how this dimensions for us? Because in SolidWorks, I've always just let it dimension for me and then just get rid of a few things, add a few that it doesn't take. When you do very complex stuff, yeah.
No, I'm not showing you that. No. Dimension properly, go through and make your drawing. Don't just auto do it. It's better practice to go through and do all your dimensions. But this isn't a very good part to show it on, but I really shouldn't have picked a tube. Frick. What's another part? Well, I have a mountain bike bottom bracket on my computer that I was going to use, but it's on my computer. Well, but it has like things. No, that's seats. Yeah, here, we'll do this one. Okay. So here's another interesting one. So like top view looked like this. Front view is sort of funky. Like our right view is not so right sort of thing. So if you hit the orient view, like what you can do is you can specify a vector, and I believe you can rotate it. Yeah, you can rotate your view to be how you'd like it to be. And then like all of your projecteds will go off of that sort of thing. But so for each of our parts, what's important to consider when you're making a drawing is how that part's going to be manufactured. Just because you can put a dimension somewhere doesn't necessarily mean that that's a useful dimension. And this also ties into the modeling practices that we shall be trying to use, in that how we set up our CAD model will affect how we're able to dimension our part, which will affect how we're able to manufacture it. So like this one, for example, we have like bends at these points. So like obviously an angular dimension for those in like the direction that you'd be bending would be something that you'd be wanting to do. And then like your distance from like your bend lines sort of thing. Oh, that's angular, rapid. But the example that I want to use is the example of the like hub, for example, where you're going to have certain lengths along that hub that you need to like have this diameter for this long, and then you're going to go to this, you're going to step the OD to this for the bearing and step it back down sort of thing. And so there's where you want to have like a solid reference datum and reference your dimensions off of that datum and have like one point that you're dimensioning from. So when we're in the shop, there's, okay, all of our dimensions are off of this face. Perfect. So we just turn that face down and then all of our dimensions can be off of that one. It's not, oh, this dimension is off of this face, but then wait, this dimension is off of a face that we haven't machined yet. So then we have to do math to figure out how we need to machine that part. So that's sort of just as you're going through your drawing, think about how it's going to be machined and what datums you're going to be wanting to measuring off of. And as you do your drawings, I'm sure you'll be sending them to your leads for feedback and review, and you'll get markups on what needs to change and such. So yeah, is there any other questions on drawing stuff? Anything we think I've missed?
Tolerance is specific to a certain point.
Oh yes. So let's just rapid dimension, not the point. Yeah. So let's go with this. So I'm sure, so this is one of those times where it's like, okay, this is 4.96. I'm sure this is a sheet metal part. So ideally the drawing would be a flat pattern drawing, and then you do your dimension on it. But so I'm sure this is supposed to be 5 inches. But if you need to add a tolerance to a dimension, just double click the dimension and this screen will pop up. And this is also where you can like edit some settings about your dimension, but essentially here it's like your point to point, whatever. But then this second one is your tolerance. So no tolerance, plus or like an equilateral plus minus, a non-equal plus minus, like unilateral, etc. So this is where you specify all of your tolerances, and then you can change those values if you need to add notes to a dimension, etc. You can do all of that in this menu here. Yeah.
That's all I can think of.
Yeah.
For bearing finishes and things like that.
So the easiest way, so like if there's a bearing finish or something, you can select like you can do a surface finish thing if you want to. That like all that's up there, like go ham for it. But the easiest way I find for like some of those things is, okay, this flat plate is a bearing surface. So just underneath here, I'll just say, C note 1. And that'll tell whoever's looking at this drawing to go look at the note section of the drawing, and they'll go down in the notes, see that note 1 is surface is bearing surface, keep tolerance, like the tolerance should be on the dimension, but follow tolerance sort of thing. And there can be a note there. So that's for any dimension. If there's like a specific thing about that dimension that's important, put like a C note and write a note in the bottom corner on how that works, or like what you need from that, and communicate that to the people machining. Yeah. Any questions from the audience? Dead silence. Who's excited to do drawings? Oh, you press note. You put your text in here, and then you just click wherever, and it creates your note. And then you can, drag that around. 12 months of my co-op experience has just been doing drawings. So I find them a little bit fun. So if you have a question about drawings, ask me. You have something?
How should we be saving our drawings so that we can use them in the machine shop?
PDFs.
So obviously, yes. So good point. We need to print all these drawings for Karen to print. So obviously you need to save that drawing file with the D to save the like NX version of it. But to save a PDF of the drawing, go File, Export. It's not in this guy.
PDF is the top one that's not. Yeah, it is. One down.
Oh, yeah, it is there. Look at that. So yeah, you can do like your multiple sheets. Black and white's fine, etc. And then just pick your folder for there, like in the GrabCAD. However, we can probably do a separate folder within each of the subteam folders for drawing PDFs. That way, there isn't a bunch of PDFs in the main folder as well. But yeah, that's easy export PDF option there. What else? Yeah. I know it's going to suck doing drawings, or drawings is seen as one of the mundane tasks that we all have to do, but it's really the most important task in designing something because it's communicating how you have to manufacture it. And for the club, it's also important because starting after Christmas, we'll be starting the cost report, which every part on the car needs to be in the cost report, and each thing in the cost report needs a PDF drawing of the part. So each drawing that we make here will be in the cost report, and then in that cost report, we'll also have how we made all of the different parts, and documenting how we've manufactured all of the different parts that we've made. So these are all very important. And there might be another special drawing project in the new year that we'll be working on as well, for those that are keen on drawing stuff. Oh, yeah. So you've done your final CAD. You've gone through it with your lead, that's approved. You've gone through your drawing with your lead or myself, and we've given you feedback on your drawing. And we say that your drawing's done, ready to go. The next step would be in the manufacturing channel on Slack. Feel free, make sure you join this guy. There's two different submission portals, I guess. One is for general machining, one's for water jetting. Just click that link and it'll bring you to a form for monday.com. In this form, just put your name of who's designed the part number and name, your sub-team, and then add the PDF file of the part that you're drawing. Then include the stock required. So for A-arm inserts, say it's 3/4 inch 6061 rod. For the uprights, it's a 5 inch by 10 inch by 3 inch block of a 6061 or 7075, whatever. Put that in, and then what machine's required? Is it a mill part, lathe part? Is it a water jet? Then CNC part? Is it a CNC part? Is it a CNC lathe part, etc.? And submit that, because that gives Kieran an email on the fact that he needs to go and get someone to manufacture that. For the water jet, it is a similar thing. However, you need to submit a PDF and a DXF file. This is something that I will, let's see if I can figure it out in 2.5 seconds. Was this part made of sheet metal? I don't know. Yeah, I think we can get flat views in here. File, export, AutoCAD DXF/DWG, export to DXF, 2D. Yeah, we'll put an updated video on how to export DXFs in an X for WaterJet, but either way, you'll have to export a DXF as well to WaterJet stuff. So yeah. Any questions on that? Nada. Okay. I know that's sort of boring and drawn out on drawings, but as we get into them, have fun with it. You can make some pretty cool drawings. I enjoy them. We need them all. One thing to note that isn't really applicable to us is up here, there's these feature control frames, like datum feature symbols, etc. These we don't need to worry about for our drawings. These are something for a thing called GD&T, geometrical dimensioning and tolerancing. It's a very interesting thing, GD&T. It's quite interesting. I might, for fun, one night give a little lecture on GD&T because it's sort of cool. But yeah, I think that sums it up for the drawing stuff.